Hello and welcome to the part 5 video 2 of the modeling and validation for the Bhutan rice mapping. So in our previous video we ran the script parameterize model.js. This script ran several combinations of the parameters for the model and we exported the charts at the end. When I went back and checked, I realized that I'm getting the out of memory error. So in this video I'll talk a little bit about what that means and how you can control that, how you can get rid of the error, and also I have an example output here which you can use for the time being to understand how you can best assess the model to be used in the next script, which is the generate and validate script. So one way you can get rid of this error is by controlling your parameters. So if you looked before, and let me minimize this, we had around 500 something models. So if you run one more time, we have trying to export 540 models. So this might be an overkill. One way you can do it is dividing your parameters into separate output. So if you change this to starting from 50 to 120, and if you can see the number that get reduced. So if you have a lower number of models that you need to export, the higher chances that the export will run. That's one way you can control, you can get rid of the error. The other way is, as I said, dividing your parameters into different files, so you can have your output in different files and then combine them later. In this exercise I have already done that, and I have prepared an example for you to analyze. This model, this is the output that you'll get in your Earth Engine folder in Google Drive, and you can download this. You can go and download this model output, and we'll look at this model output together. So here I have already downloaded and loaded my model output, and so this is your system index. That's the number that's automatically assigned. Back fraction, remember we started with 0.5 up to 1, and this is repeated for different parameters. To make it a bit more easier to read, I'll move the importance in another row. So here's the importance for different model run, maximum number of nodes, mean leaf population, this is just the model name, number of trees, all these parameters, and here's your output from these different models. So let's move this and paste it at the end, so it's a bit easier to read. So now we can go ahead and expand, so you can see these different variations over here. So now you can choose your model depending on your application. You can try to maximize your F1 score, or try to maximize your test kappa, and again, depending on what kind of applications you're working on, you may try to also generate some other statistical measures here and try to maximize or minimize those. For this exercise, I will maximize the kappa. So I'll try to sort this in largest to smallest and expand this selection. So I have a highest kappa score of around 70%, and for that 68.96%, I have a precision and recall, and F1 score actually the same, so there is a good balance on the precision and recall, and that means there will be good balance on the F1 score. So this model is pretty good, and we also have a high accuracy. So if I were to use a model that would try to maximize the F1 score, I can do that as well. And if I do that, okay, so interestingly, I see that I still have the same kappa, but my F1, but my test accuracy has increased a little bit, and I think my number of trees also increased a little bit. So let's go back and sort this again by largest to smallest. Okay, that didn't change. So it's still the same model. It's 555. That's the model we're looking at that has everything maximized across the board. And sometimes if you see two models that have the same score, but you see that the number of trees is varying or other variables are varying, you want to select the model that is more simple rather than complex, and also you want to minimize your number of trees so that your model is not overlearning, it's not overfeeding on your data set. So I'm gonna go ahead and select this model 555. In fact, this is the same model that we used in our paper. So I'll go ahead and I'll copy these, because yeah, I'll just need this. And so this is the parameter that we'll be using in our next script, which I'll show you next.